Hello Internet, my name is Quinn and this is Blondihacks. Today's project is something that I've been thinking about for a while. I would like to put a DRO on the quill of my lathe. The primary use case for this is for really accurate drilling depths, which I'm going to be needing to do a lot of pretty soon here on my locomotive project for plumbing fittings, valve bodies, that kind of thing. So let's go. My current solution for accurate drilling is to put a toolmaker's clamp on the quill and then an indicator on that. And that works okay. It's certainly accurate. It's been very effective for me so far. However, it has some limitations, as you might imagine. In the plus column, I can still move the tailstock, so that's handy. I can leave that contraption on there for limited amounts of time. It's not too in the way. However, on the downsides, the indicator reads backwards, of course, because it's extending as you drill deep. So being an analog indicator, you got to do some mental math to make sure you get that depth accurate. That's a potential source of error. And then of course the indicator travel is limited. It's much less than the quill travel, so you do run out of range pretty easily. And frankly, the whole thing is just really fussy to set up and kind of tedious, and I want something more convenient. A digital DRO permanently mounted to the tailstock would solve all of these inconveniences. I'm obviously not the first person to think of this. This is a pretty common thing that people do to their lathes. I think the first person I saw do it was Mark Presling, and recently a bunch of my patrons have shown me their versions of this, so lots of prior art to work from. Every lathe is going to have different challenges for this job. The first one that I'm going to have is the ejection limit on my quill. When you wind the quill back to eject tooling, it ejects fairly early because on the drill chuck it has a drive dog that's used by drill presses and larger lathes for large diameter drills to handle the torque so the taper doesn't slip. However, for my other tooling like my centers, they are much shorter. They don't have that drive dog on the back, and the ejection point for them is all the way in on the quill. That means there's no room to put any kind of clamp or anything on there to attach my DRO scale to. We'll need to solve that problem somehow. Let's take a look at the DRO that I want to use. I have this guy, which you may recognize. This is the DRO that I removed from my milling machine because I didn't like it on my mill, and I replaced it with a different one. However, the things that bothered me on the mill will not bother me on the lathe, namely the limited viewing angle of the LCD and the quirky auto power-off behavior that it has. I already have it also, so that's a very strong point in its favor. I of course need to ensure that the travel on the scale is going to be sufficient for my quill. Wasn't too worried about that because this quill only has 2.5 inches of travel, and this scale has quite a bit more than that. However, the more travel that the scale has, the more options I have for positioning the head unit on the tailstock. Speaking of which, I have some options. I could mount it on top like this. It looks pretty good. There might be some clearance issues with the locking handle. I could also mount it on the back at an angle, but that would be even worse for the locking handle, and it would be sticking up kind of in the way where it's going to get caught on things. I could put it down low and in front, which I kind of like, but that's going to have clearance issues with the compound and the cross slide, so that's not great. I could put it on the front, flat, which could be hard to read, or at an angle, which would be easier to read, but would be kind of in the way. However, the thing I like about having it on top is that I can then grab the tailstock on the sides for moving it, which is my usual way of moving it back and forth, which of course you have to do a lot. So that's really appealing. The top is the only option where I can still grab the tailstock by the sides that doesn't also have other clearance issues. And I think I can work around the clearance issues with the locking handle. So this is the way I'm leaning right now. This method would, however, block the markings on the hand wheel and the oilers. I could theoretically get around both of those problems by rotating this flange on the back 90 degrees, but honestly that doesn't work very well because the flange isn't actually square. It's close, but not quite, so it looks a little funny. So I'm not too worried about that. I can still access the oiler with the scale all the way forward, and the other oiler on the top of the tailstock is actually not very necessary because you can just wind the quill all the way out and put some oil on it and wind it back in. So I don't mind losing access to that. Let's solve that tooling ejection problem then first, because that's a deal breaker if I can't do that. I'm going to take the tailstock apart, taking a look at the parts diagram in the manual to see how that might work. At the end of the lead screw in your tailstock, there's always an ejection pin, and that's what actually pushes on the back of the taper to pop it out. My thought was if I can make that ejection pin longer, just by a little bit, just enough to give me enough thickness, enough stick out on that quill fully retracted, then that will solve my problem at the cost of an insignificant amount of loss of quill travel. These little lathes are not very complicated, and getting this thing apart is not very difficult. Removing that flange, we can see a 3-part thrust bearing on the back, as we would expect to find. Then I can unthread the quill lead screw. It's a left-hand thread, so that's why you see me turning it righty-loosey. And you can also see the final third of the thrust bearing on the back. Then the quill will pull out the front, along with some sort of mystery goo, grease, leftover factory scunge on there. And you can see the bronze lead screw nut that's pinned into the quill itself. Once again, you can see how the lead screw threads into the back of the quill, and then that little stubby nubbin on the end of it is the ejection pin that pops out the tooling. How then might I be able to extend that? I could tap a thread in that and screw something to the end of it. However, that is a center, and I don't like to destroy a center, because if you ever want to rework this thing, if you want to clean up the thread or straighten it or do any kind of repair on it, you need that center. So instead, I'm thinking about making a cap that goes on over top, and it'll be a close-fitting cap that just Loctites in place, fully reversible, and don't do any damage to the center or any other part of the lead screw. That cap will need to thread through the center of the threads on the nut, so it needs to be smaller than that and still big enough to go over the nubbin on the lead screw. That's going to leave me with a pretty thin-walled part as shown in this highly technical drafting that I made. However, I think we can get away with it. So I'm going to make this out of bronze, and I'll do that, of course, over on the lathe. Start by cleaning up the end of this piece of stock. Once I have that to an exact diameter that will go over the ejection pin on the lead screw but still pass through the center of the lead screw nut, then I'm ready to move on to the next step, which is to counterbore the end of this thing to fit over the nubbin on the end of the lead screw. To get started with that counterbore, I'll rough it in with a drill, just bringing the tailstock to get my drill chuck in there and... oh, right. Don't panic, we can work with this. I think if I just very carefully... yeah, there we go. That should work, right? No, of course not. No, that's ridiculous. Just gonna understand a little bit of this, a little bit of this, a little bit of that. There we go. Now this will work. You thought I was going to do that other thing. That would have been crazy. This counterbore needs a very accurate drilling depth to start it. If only I had some way to do that on my lathe. Yeah, well, so I got to do this setup one more time. Hopefully for the last time. And yes, in case you're wondering, I did disassemble and reassemble the tailstock about 15 times during this project. It's kind of unavoidable doing something like this, especially when you need to use the machine tool to make the improvement to that same machine tool. With the drilling done, I'll then finish that out to final dimension and square up the bottom of this counterbore with a teeny tiny adorable boring bar. This needs to be a nice close fit over the end of the lead screw, kind of within Loctite 680 range is the goal, so 1 to 2 thou clearance maximum. And Jahtzee. I can do a test fit now and make sure this is going to work, make sure I got the length on that right. So I'll set that on there temporarily, thread it into the quill, and we can do a little test ejection to see if my extension on the ejection pin is going to give me enough leeway on the end of the quill to clamp my DRO scale. So it ejects right there, and I've got, yeah, a little more width than I need for my clamp. So that is perfect. That's going to work. Next, I'll whip up a mounting plate for the head unit on the top of the tailstock. The nice thing about these Asian import lathes is that all of the castings on them tend to be square, which is not as pretty as the old South Bends and Craftsmans and such. However, it is very practical because it means you can set indicators on things and attach things to nice flat surfaces. 2 center holes mount this to the head unit, and then I checked the hardware that I want to use to make sure I've got enough meat in the tailstock casting to tap threads, and I do, plenty of room there, so I'll drill and counterbore these for the heads of those screws that I chose. That's looking very good indeed. I'll flip this over now and counterbore the backs for the heads of the screws that are going to mount to the head unit. These are little button heads. And finally I'll round the corners of those to make them nice and so I don't stab myself on them. I can get this in position now, and I need to measure the distance between the quill and the end of that scale. That's the really critical dimension for the clamp. I decided to use one of the mounting brackets that come with these scales so that I don't have to drill holes in the scale itself. I've learned the hard way from experience that those scales are extremely, extremely hard. They're not easy to drill through. Now this scale has holes already drilled in it at the other end, so I actually tried flipping the scale around, but that doesn't work because then the head unit reads incorrectly. The quadrature encoding that's in these scales has to be oriented the correct way or the digital reading doesn't work. But now I have the height of that mounting boss that's going to need to be above the quill for the end of that scale, so I can start laying out for the clamp that's going to go on the end of the quill and hold that end of the scale. I'm going to do this with layout because there's nothing too critical here dimension-wise, except for the bore itself. I'll want that to be accurate, but everything else is pretty much decorative. So the two critical dimensions being the bore and the height of the boss above the bore, those I'll be doing with the DRO, but the rest of these I'll be milling to the layout lines, and it's going to look very nice, I think. Starting with that bore then, I'll do it on the lathe. I'm going to get the center punch mark that I used to describe that circle centered up on the lathe. I used some parallels and some tapping to get it parallel to the face of the chuck since I'm holding it in the ends of the jaws. And then I'll dial in that dead center to get my punch mark on center. And then we can drill and bore this out. Quick ichrometer check says it's concentric, so let's get down to business. I'm going to rough this in with some drills, save myself some time with the boring bar. That drill chattered a bit, and the really big drill chattered more, but it doesn't matter because we're going to be boring this out, so a bunch of ugly chatter marks in there are not going to hurt anything, except our ears. And maybe the cat. This dimension is the most critical because a clamp like this is a flexure. There's no pivot point in it anywhere. And the secret to making a flexure work like this is to make sure that it has to move as little as possible. So if you can get it to be extremely close fitting in the unclamped position, then the clamping doesn't have to flex the material very much and it will be effective. Basically the same as a 5C collet. That feels very, very good. I can just slide that quill in there, so that's perfect. Moving on then, I'm going to remove the excess material around the outer round area on the bandsaw, save us some milling time. I'm going to start by making the boss feature at the top that holds the end of the scale. So to get this indicated in, I'm going to use 3 pins. I need to get that boss area roughly square, just using a square and by eye is good enough. Make sure it's snug against my pins. And now those 2 big outer pins give me the center of the circle on X. And then the smaller center pin, along with a feeler gauge, will allow me to bring the end mill down and find the top of the underside of that bore surface, because that's the dimension that I measured for where the height of the scale needs to be. So once I'm touched off on that pin with the feeler, I can move clear, go down the thickness of the feeler, zero the DRO there, translate up the height of the boss that I need, and machine away. And then I can also clean up the sides while I'm here, and then drill and tap for the mounting screw that's going to attach that bracket that holds the end of the scale. Before I go any further, let's make sure I got that critical dimension correct on the height of that boss. If I don't have that correct, now is the time I'd like to find out. I can mock this all up here and just make sure that I'm going to have nice smooth travel on that. If the height is wrong, then the scale will bind up at some point in its travel. But that actually looks really good, so I think that will work. On then to the rotary table to do the outside shape of the clamp. For that I'm going to use my sacrificial rotary fixture plate that I showed in a previous video. And I'm going to get my piece centered up by tapping it in. The rotary table itself is already centered on the spindle, so I don't want to move the table, I just want to move the part on the fixture plate. Once centered, I no longer need access to the bore, so I'll use the bore for clamping, and then I can remove one of my 2 strap clamps and get access to 90% of the outside area of the part that I need to machine. I don't want to rely on just that center clamping point. I never trust a single bolt to clamp something unless I know it's a really light cut. So I'll leave the extra clamp on there and I'll remove it at the end and clean up the area that's blocked by that clamp. And as I said right at the end, now I can place some musical clamps. I add a new clamp and then remove that existing clamp, and that gives me access to that final little area that I couldn't reach. and I mill right up to the side of that boss. Now, of course, I can't reach right up to that boss because of the radius of the end mill, but I can clean up those little corners with a file. Next feature I want to do is the clamping bolt that's going to clamp this to the quill. So I'm going to set it up on the edge of the vise like this to give myself vertical access. Once again, squaring it up by eye and by feel is sufficient for this. And to get myself centered on the right place on the edge of that clamp, I'm actually just going to bring in a drill the same diameter as the bolt that I want to run through here and visually center it on the meat of that clamp. I want it to go down through the side of the curve and of course not break out into the inner or outer part at any point. And that's just as easy to do by eye as much as any fancy math, frankly. I start by bringing in a 2-flute end mill to create a flat spot going down as far as I need to. Then I can center drill the flat spot, then drill all the way through with the tapping drill. Then I need to open up the top half of the hole with the clearance drill. However, finding the top half could be a little tricky, but luckily we can use an old machinist's trick of pinning something straight to the side of the curve with something sharp, in this case a punch. When the straight thing is vertical, then I know the punch is on the center line of that curve, so I bring the end of the drill down to where the punch is, zero my quill DRO there, and I know how far down to drill to reach the halfway point. So I open up the top half of this hole with the clearance drill, and then I can tap the bottom half of this hole. And then once there's a split line right between where the threads start and where the clearance drill ends, that's going to create the clamping action. This doesn't actually have to be as precise as you might think. If you end up with threads above center line, you can drill them out with the clearance drill after you do the split line. Or if you end up with a little bit of clearance drill down below the center line, it doesn't hurt anything as long as you've got enough threads in there to clamp with. But that looks like that's going to work. So I'll bring in the slitting saw now to do the cut, and I'm going to center it vertically the same way I did with the punch trick. And away we go to make the cut. I used to worry a lot about getting all of the dimensions absolutely perfect when doing a round clamping feature like this, but I've learned over the few of these that I've done that getting the split line exactly on center and the threads and the clearance holes exactly ending in the right place actually doesn't matter very much. You can miss a little bit with all of this stuff and it still works. That looks pretty good, but I'm going to go and test it on the quill and make sure that I actually get clamping out of it. This clamp is pretty thick, and I may have to add a flexure joint on the other side of the split line for this to actually clamp. If the little threads aren't strong enough to deflect the material, then it won't clamp, but that actually is looking really good. If that doesn't work, then you just put a little slit with a hole at the end of it. You've probably seen flexure joints like that on the side of the part opposite the split line, and you can weaken the material as much as you need until you get a clamping action. I'll do a test fit now with the scale, and I want to get the head unit now mounted in the correct place. So I want to make sure I've got enough travel on where the head unit is, and I'm trying to get it as far back as I can so that the locking handle has clearance. Then I'll transfer punch the first mounting hole. I'll center drill that, and then I can get in here and drill that to tapping depth. For that, I'm using a guide block, which is just a block that I've drilled on the mill or the drill press so I know it's square, and that will keep the hand drill square while drilling this hole. Of course, I can't get to full depth with that block in the way, but once I've got the hole started, then it'll finish straight because most of it is already straight. And I realize the drill looks a little crooked in this, but that's just the camera lens. It's a wide-angle lens, and it tends to distort the straightness and squareness of things. Then similarly, I tap that with a tapping block to keep the tap wrench square. This block is just a squared up steel block with clearance holes for various size taps in it that I keep around for this type of thing. It's an easy little tool to make, and it's very, very handy for freehand tapping. Deburr that, and let's have a test fit on there. Now I can put one bolt in, and not too tight, and then I can wind it all the way back and all the way forward, and everything will kind of self-align. Make sure that there's not going to be any binding or anything anywhere. And then once I've run that in and out, I know everything is straight because if it needed to shift, it has shifted itself. Then I can transfer punch the other 3 holes and drill and tap those. That looks good. Fun fact, the top right threaded hole has almost no threads in it because I hit an inclusion in the casting on that one. So, one of the 4 bolts is moderately decorative. Okay, first moment of truth. Let's see if it chooches. Oh, indeed it does. That seems to be really good. There's no binding anywhere. Everything's moving smoothly. The numbers are numbering. I was a little bit worried that this scale was going to add a bunch of drag to the cranking action on the quill, because the scale is actually quite difficult to move by hand. It has a big heavy spring inside it for drag, but honestly I can still move it really easily. I can still free spin the handle. So good news there, no noticeable increase in drag on that quill at all. And my favorite part, I can still grab the sides of the tailstock and slide it back and forth, which I have a lot of muscle memory on that I did not want to lose. The locking handle also still works. It doesn't need a lot of range of motion, fortunately, to do its job, so 90 degrees is really all that handle needs, and it has that. The real test, though, can I still eject my shortest tooling? Oh, there it is. I've still got a little bit of room to spare. That's metric horns of victory. There's my little Tailstock Quill DRO install. That seemed to go really well. I'm super excited to have this now. It's going to be a big quality of life improvement for me. As I said at the top, every lathe is going to be different, but maybe you got some ideas in here about things you can try if you want to do this to your lathe. If you have one of those older lathes that has all of the pretty Art Deco curves on it, then I do recommend checking out Mark Presling's version of this same project, because he dealt with that challenge and had some great tips on how to mount the head unit to a non-square flat surface like I had the luxury of doing here. Well, thank you very much for watching. I hope you enjoyed this. I do love making these videos for you guys. It's so much fun for me. I hope it's fun for you too. Thanks to my patrons for making it all happen, and I'll see you next time.